Hey guys, today we're going to be talking about when waves, specifically light, interacts with a boundary, and we'll do one of two things. We'll either reflect or refract. If it reflects, that means it stayed in the same medium. This is really simple, very important facet of reflection. That if a light ray, so we could draw the wave fronts in here, of course, but I'll draw the ray. And of course, we measure the angle with respect to the normal line here, that line perpendicular to the surface, to the boundary. And we call this the angle of incidence. For reflection, if the light stays in the same medium, it means it bounces off of the boundary and it reflects, such that these angles are exactly the same. Why do they need to be the same? It's almost too easy, isn't it? I mean, it is easy. It's intuitive. Sure, if you've played billiards before or any game where there's bouncing, you know that the angle at which something enters is the same at which it leaves. Of course, assuming no spin. If you put spin, that ruins everything. The answer, of course, is the wavefront. And of course, the speed of the wave determines the wavelength. Right? Remember the wavelengths? Yeah, so if the wavelengths stay the same, I can draw those in red here. Then, of course, the wavefronts will reflect off such that the wavelength does not change, therefore the angle cannot change. And that should make perfect sense. Easy. Easy done. And of course, if the surface itself is curved, you would take the normal line perpendicular to that tangent at any point in the curve. And we'll do that more together. We'll explore that in class with mirrors. For refraction, that is when, of course, the light passes through the boundary into the new medium and it changes mediums. For if it changes mediums, of course, that means it is still incident. I'll call that medium 1. And therefore theta 1, and I'll call this medium 2. Therefore theta 2. So will the angle stay the same? Well, as we already know, it cannot. It cannot stay the same because the velocity has changed. Yeah. Therefore, the wavelength has changed. Therefore, the wavefronts will be a different size. In fact, they will be shorter here. I don't know if this is helpful, but I'll do it anyway. Here in air, they're longer, they're farther apart. Oops. And in water, they will be closer together. And of course, that means they must bend inward, and therefore the angle must change. So the general rule for reflection is when any wave, of course including light, light is a wave, is incident on a boundary between two mediums, and it stays in the same medium, it will maintain the same angle. If it transfers through to a different medium and it changes mediums, of course the angle must change. The only thing that's guaranteed here is that theta 1 does not equal theta 2. And tune into the next video to see the details of whether it, of course, bends inward or outward, as will hopefully be an easy review, and we will include the index of refraction in that discussion. Thanks, guys.